now we're going to talk about problem solving strategies. And the thing to keep in mind is that this is often a highly abstract concept for students. And so it's not as much about memorizing the strategy as being able to apply it. So our learning objectives is to be able to state the 4 steps, use a diagram, trial and error, problems involving money, or problems with calculation. So we're going to apply this problem solving process to several different types of problems to help you tangibly see how it works, just like you would want to do in your classroom. So the 4-step problem solving procedure is to understand the problem. And so we have to teach students to read the problem slowly, and oftentimes instead of jotting down key ideas at the lower levels, we circle them, we underline them, we use a strategy like that so that students aren't having to rewrite things. Once you've identified what's important and you know what the question is asking you, then you need to devise a plan to solve the problem. And in that plan, you might be drawing a diagram. You might be looking for a formula. You might be trying to use inductive or deductive reasoning. You might be looking for patterns. Once you've got the plan, you're going to carry out the plan. So you're going to solve the problem by applying the formula, by finishing the diagram, by finishing the pattern, or giving, maybe it's an equation it's asking you for. And what's really important is that we stress step 4 to students. It's so important to check your answer and to ask yourself, does my answer make sense? Because that's the critical thinking skills that we're really trying to instill in students when we're doing problem solving. So here's an example using a diagram. In this example, we have a gardener and he's planting 8 tomato plants. So we would probably underline 8 that are 18 inches tall. Okay, underline that. And a straight line with 2 feet between each plant. How much space is needed between the first and the last one? So for me, I would be using a diagram problem because it makes sense. There's not really a formula for this, so there's no way around it other than to actually start, solving and drawing the diagram. So to understand the problem, we've underlined all the key information from when I read it, and we're asking you to find the total distance from the first tomato plant to the second tomato plant. So if I'm going to devise my plan, like I said, we're going to draw a diagram because that makes the most sense here. So you can draw any diagram. If you're an excellent sketcher, you could draw little tomatoes, but I've got my diagram drawn and I see that, well, now that I have my diagram, all I have to do is add the spacing between the plants and I get 14 feet. So since there's 8 plants, but only 7 spaces between them, 14 feet should feel right. In part B, our drawing was designed for a highly specific problem, but I could use it for something that's more general. So it shows us that for 8 plants, there are 7 2-foot gaps. So I could deduce if I had 9 plants, I would take 9 minus 1, so I would have 8 gaps, and so my total length would be 8 times 2. So I could call it n plants. I would have n minus 1 gaps, and my total length would be 2 times that n minus 1. So this goes back to our previous lecture where we were talking about abstracting with deductive reasoning. What if I have a perimeter problem? So in this problem, we've got a campus group, and they're setting up for a tailgate bash, and they give us a couple of different important pieces of information that I have to filter through. And it's really good to highlight to students. It doesn't matter what's happening about there's a campus group or there's a tailgate bash. That's just contextual information that helps you relate this to a tangible experience. So when I'm understanding the problem, I know it's a rectangle and that's important. So I'm going to underline or highlight the rectangle. A rectangle has 4 sides, and I'm told the width is 100 feet and that the 4 sides add up to 440. If the sides add up to 440, that is a perimeter, and that's probably going to be a gap you're going to have to point out to a student is, if I add all the sides, that's the formula for perimeter. So to devise a plan to solve the problem, this is another one where I would use a diagram, but you could use the formula. But definitely, since we're working with younger students, we would want to actually draw out the rectangle and show them that we know because it's a rectangle, we have two equivalent sides of 100 feet. I know there's 440 feet total of fence, and I've accounted for 200 feet. So if I do the 440 minus 200, that leaves me with 240. And a lot of students would just say that the length is 240. But when you have the diagram sketched, it becomes obvious that you have two sides you're solving for that are both the same length. So I have to divide those by 2, and that's how I get the 120. And so I would want to check and be sure that I'm correct, that I'd have 100 plus 100 plus 120 equals 440. If the student did make the mistake of saying that the sides were 240, they would realize that error in step 4, which is why step 4 is so critical. What if I'm going to use trial and error? Trial and error can be very frustrating for us as adults, but it can be very meaningful for our students because every time they make a mistake, they're going to learn from it, and that's going to give them new information for solving problems. So part of my duties as a new hire at a job is buying door prizes. So I'm going to read through the problem. I've got several different monetary amounts going on. And then I have that whole piece in parentheses, which really isn't relevant to the problem. It's just interjecting some real world sense. So when I boil this down to the simplest parts as I understand the problem, I have 12 items. That's what I want to highlight. I have $110 to spend. That's important. It's $11 for each cup and $8 for each stand. So that's all of the important information. And then what they're asking me to do is find how many cups and how many stands will result in $110, because that's all I have to spend. So when I'm devising a plan, this can be a bit tricky because a diagram doesn't make sense, but some students may want to actually draw it out, and that's okay. But basically, we're going to trial and error. So I can figure out the cost by taking the number of cups times 11 and the number of stands times 8. And I can basically just trial and error this to find this. So if I use 1 and 11, that gives me $99, which isn't correct. So I need to do another trial and error. So I would try, okay, let's try 2 and 10. That's not it. 3 and 9, still not it. 4 and 8, not quite. And 5 and 7. So we're basically continuously trying those combinations by taking the number of cups times the cost plus the number of stands times the cost. At this point, we can stop because we've gone over our $110 target. So since the last row is out because it costs more than what we budgeted, so the best we can do is get 4 insulated cups and 8 smartphone stands at $108. So if I go any further than this, I'm going to break my budget. So this row is the answer because you can go up to 110. You want to get as close as you can get to that 110 figure. So here we now have $2 extra. Then I'm going to check your answer. Well, the nice thing about trial and error is we actually do the answer checking while we're doing trial and error. So what if I want to do something with a salary? So younger students often have some issues with salaries, so we tend to give them problems about like a lemonade stand or pieces like that. In order to understand the problem, the information that's important is I get $19.20 per hour and I work 40 hours a week. There are 52 weeks in a year, so if I'm trying to figure out my annual salary, that 52 weeks is very important. We're asked to decide if that will work out to be more or less than $41,000. And the fact that we get 2 weeks paid vacation, it doesn't matter because it's paid. If it was unpaid vacation, then that could matter, but this paid vacation doesn't matter. So I can use multiplication to find out how much I'm paid each week and then take that and multiply it by 52. So if I make $19.20 an hour, I would do $19.20 times the 40 hours that I work from the problem, and that's $768 a week. To find the annual salary, I take that money and I multiply it by 52, which gives me $39,936. So my annual income then is going to be less than the $41,000. So I would want to take the salary position because that would put me in a better personal situation. We can check our answer by taking that 41,000 and dividing it by 52 to get the weekly pay. So the weekly pay is also higher than the weekly pay of the hourly job. And then to find out how much it is an hour, I could take the weekly pay divided by 40, and I see again that it confirms that that is the better option for me. So in this problem, we're going to use some calculations. So I've got the problem. I need to understand what are the important pieces in this problem. Well, I need to know that I have to burn 3,500 calories to lose 1 pound. If I burn 100 calories per mile, that's important because that helps me decide how many miles I would need to walk, etc. And the problem is asking me to find how many miles per day the person has to walk to lose 1 pound in a week. So to solve this problem, I need to know how many calories need to be burned each day and then divide by 100 to see how many miles need to be walked. So since I need to burn 3,500 calories over 7 days, I would divide that by 7 to say this is the daily amount I need to burn, which in this case is going to be 500 calories. So I'm going to take that 500 per day that I have to burn and divide by the 100 calories per mile, and I find that I have to burn 5 miles in order to lose 1 pound. So if I check my answer, I can say 5 miles per day times 100 calories is 500 calories per day. If I multiply that by 7, I'm going to see that I get the 3,500 that I need to get in order to lose the pound. This example is all about recognizing a problem with no solution. So this is not common at the younger age, but this is something that we want to teach students, that there are times when there's not a solution. So when I try to understand the problem, I have these two test scores of 78 and 84. And I'm being asked about the average for 3 tests, and specifically that I want that average to be at least a 92. So right here, I'm kind of like, going from a 78 and an 84 to a 92 is quite a leap. So the way I'm going to plan to solve this problem is to start seeing what the average would be if she scores 100 on the test. Because I know that 92 is so far from 78 and 84, that's why it's logical for me to try it with 100 points. So if I do that 100 points and I plug it in, I see that the average is 87.3. So this is really bad news because essentially even if she makes 100 on the test, her average is going to be an 87.3, nowhere near a 92, so there is actually no solution to this problem. And, every now and then you might get a student's like, what about bonus points? Well, when we're talking about a word problem in math, we're always assuming 100 points is the highest you can score. So problem solving is really important, and following those steps, and while as an adult I could solve it in fewer steps, the students really need to see you consistently walk through each of these 4 problems for the entire school year. So it's not just something you teach in the unit on problem solving, it's something you're going to apply across all the units you teach throughout the school year.